Good morning, early birds. How are you? This is Dr. Annette Feravich. We're outside on a beautiful early bird morning. Thank you for joining me in the classroom. I'm the teacher, and can you believe it? I know. We're all here on time, and we're all organized, and I was like, wow, where's my hard drive? I can't find my hard drive. You want to know where it was? That was the last thing I had to do, find my hard drive. You want to know where it was? Other than maybe wake up my face, although I did shower this morning. You want to know where my hard drive was? Right there. Right. Hold on just a minute. Right there. Right there. Right underneath my stand. That's what I spent all my time this morning looking for while I was running late. A little late. But hardly late at all. I got that ABC video up there. And we are really ready for you today. We as in me. I'm really ready for you today. Lucy's apparently getting a little excited. Lucy, in your basket, please. Because we had really bad reception yesterday. And so I re-recorded the stuff that I thought was most important that we missed. And that was all the information for me that I believe was most important on the leaves. Now, also, the math was most important. So what was most important then? Well, it's kind of like, what is the greatest commandment? There's two. What was most important then? We did the math as well, and I lost all the math, and I was so disappointed I lost the math, and I was so disappointed I lost a lot of that. But I was excited to go back and do a few things, and I'm looking right now at my tomatoes, my little tiny tomatoes that are growing, and it's the only thing that grew this year, right? So nothing, all hundreds of dollars on seeds and soil and everything. And if you don't buy their seeds, apparently, you can't grow even corn, not even corn. The corn withered up and died as soon as I brought it outside, and we've had wonderful weather for corn. So that was really sad for me. I don't think I've shown you. I think I did, but not when it was complete. It's completely dead, completely. Everything else around it is living, except for the things that they tampered. Remember this, though? Oh, it's just so strange to me. Look at that. Right? I forgot what those names are, but we're going to get to the names next Wednesday in our science, because I also went around and really had a hard time identifying trees. I know a maple and I know an oak, and that's about it. I know an elm looks kind of like an oak. That's all I got. That's all I got. I know dogwoods, but I don't know exactly what their names are, right? Because there's all kinds of dogwoods. But I do know my tomato plants because when I was little, we had a tomato garden. We had a garden with tomatoes in it. And not only that, yeah, we had to pick off the tomato worms. They were awful, awful creatures, the most awful creatures. Oh, and yeah, and we canned tomatoes too, like old-fashioned people during old-fashioned days. We didn't can them during old-fashioned days. We were like old-fashioned people during old-fashioned days. That's what we were like, kind of. There they are. There are my 2 tomato plants. Well, there are my 2 pots of tomato plants. Look at, can you see all the little tiny dark balls on there? They're just getting bigger and bigger, and so many more. So many more. I'm so excited, but it's only the big plants. None of the small plants are getting flowers or tomatoes on that. So I'm really disappointed about that. Okay, so I really do want to get my coffee and wake up my face a little bit because it does seem like it's not very awake. You know how that goes. Get some sunshine. Get some sunshine. Okay, so let's take a look at with my glasses here first. Hold on. I knocked over my computer twice in the last month, but I like to say at Macintosh, you make an awesome computer. You do. You make an awesome computer. It took a long time for me to switch, but I did, and I was happy. Ooh. How did we not get that up there? Woo. Okay, we're going to start with this. I forgot about our placemat values, and I do want to do our placemat values because we're up to 100,000 and then we get to 1,000,000 and then we're done with our placemat values. So I did really want to, I did decide that I really wanted to do that. So let's go and see about bringing that up. Oh my gosh, I can't believe it. You just totally can't. First try, and they're up there. Open. Not even a problem. And this is the awesome one that I've got because this is the one that I've got that I can write on. So I am just very pleased. Let me see if I can't open that up a little bit. I think it's just fine, don't you? I mean, we've got the important part of this, right? Which you know what that is. Got the important part on the screen. You all know what that is. Okay. I think there we go. I like that a little bit bigger. How's that? Perfect, Dr. Feravich, just perfect. How do you do it? Well, you know, it takes a lot of time, a lot of hard work, a lot of late nights, but you know, you do what you got to do. So let's say that we have, now remember, we are separating our hundreds from our thousands by a comma, right? So let's try a number like, off the top of my head, a number like 726,000. So every 3 places, every 3 digits, every 3 place values, we always put a comma. 385. I think I got most of the numbers in there, didn't I? I did. 2, 3, oh no, 4, 5, 6, 7, 8. Okay, so how many ones do we have? We have 5 ones. You know, when I was doing this in school, I always thought that this was silly. How many 10s do we have? We have 8 10s because the 8 represents 80. So basically, we were just writing the number all spread out is what I thought. 3 represents 300, right? That's not 3, it's 300. Which is okay that it's easy, right? It's okay. We've got the comma there, right? We put our comma in like we're supposed to. Let's highlight the comma there. But it's about a concept, all right? It's about a concept. How many thousands do we have? We have 6 thousands, which makes 6,000. A little bit better writing there than the last 300. Yikes. How many 10,000s do we have? 10,000s. We have 2 10,000s, which makes what? 20,000. And if I'm doing this right, I put my commas in there as well, right? To separate after every 3 digits. 100,000s, I have 7. I have 7 100,000s, which makes 700,000. So again, place values is all about the concept of understanding that that 2 doesn't represent 2. You just need to understand that 2 represents 20,000. You need to understand that that 3 is not 3. That 3 represents 300. It's not a hard concept, right? It's not hard. It's not 5 plus 8 plus 3 plus 6 plus 2 plus 7. Right? It's 726,385, right? That's how we say that. So we say that 726,000, because that's exactly what it is, isn't it? Here we have 726,385. The 8, Lucy, you're going to go inside. You're going to go inside. Inside. See? No. You saw all them all week. No. Inside. I got to get her inside because she's getting too excited. Lucy, sit in your basket. Come on. Sit down. No. Don't you dare. Sit. And I think she's done. She's seen him all week. So. Okay, so again, we do a really, really good job trying to understand the concept is what we're doing, right? Oh, there we go. I was like, it doesn't erase the highlight. What? All right. So we want to understand the concept of a number. Let's do another number. Let's try and read the numbers. All right. So this number I'm going to write is going to be 48,633. We put our comma where it belongs, right? How many? Lucy, sit. Now, she gets distracted and she gets a smell, and then she's like we do. Oh, food! I need food. She does that for all kinds of smells. So we get used to saying the number 48,633. How many hundreds do we have? We have 6 hundreds. How many ones do we have? We have 3 ones, right? Let's try one more. Let's try another 100. Maybe we might try 2 more. Let's try another 100,000. Let's do this one. What is that number? What is that number? That number is 222,222. That's what that number is, right? How many 10,000s do we have? Well, that should be easy. Just take a guess. Take a stab. Two. Two 10,000s, which makes it what? When we have two 10,000s, two 10,000s. Two 10,000s. Which equals 20,000. Which is which digit there? Which digit are we talking about? This one, right? This digit right here. Two 10,000s equal 20,000. Excellent job. Let's see what the guys are doing. Oh, cleaning up. Want to take a look at some hard work? Lucy, get up here. I don't know why I'm not getting the stream. Oh, I do know why. Because it's connected to the other one, isn't it? See what that does? Oh my goodness gracious. It is just so unbelievably annoying. I manage it. I connect it to one stream. I have a second backup stream in case we get disconnected, and it connects to the backup stream instead. Very, very aggravating. Very, very aggravating. Lucy, come on. In your basket. She's a good girl, though. She listens. She comes right up. Okay, so we're going to have to be really annoyed and edit this. We're on live. Oh, look at that. Oh, I want to show you guys something about what that guy just did. Oh, I wish I could see him do that again. It's a balancing thing. He pulled up a 12-foot board right from the ground. And he did it with ease. How did he do it? He did it by what is that called? It's balancing, but it's something else. I can't remember what it's called. It's a distribution of weight. Lucy, where are you? Okay, good girl. All right, now let's get going to our money that we did yesterday, but we didn't get it recorded. All right, so let's quickly get to our money. And as in quickly, I mean, where is it? Oh, that's not what I wanted. There we go. Okay. So there we go. All right, excellent. We're going to hear some music as well. So all right. Can make this bigger. We get a little Spanish lesson here behind us as well. Okay, so When we have a dollar, how many pennies do we have? We have 100 pennies. 100 pennies equal $1. If I broke that dollar into 100 pieces, basically, it would be 100 pennies is what I could break that into, right? As far as money goes, we know that 100 pennies is, or 1 penny is the smallest amount of what we call currency, right? Money is also called currency. So 1 penny is Lucy, in your basket. 1 penny is the smallest amount of currency that we could go, right? $1 is the smallest amount of paper money that we can go, right? Of paper money that we can go. 100 pennies equal $1. You know, this thing is slow, is what it is. A fraction is part of the whole. 1 penny equals 1 out of 100, or 1/100th, right? 1 penny, if 100 pennies make $1, then 1 penny, 100 pennies make $1, then 1 penny is 1/100th of $1. That's how we say that. So here, one out of 100 is also called 1/100th, right? You can see that that penny clearly is 1 out of 100. Right? Lucy? Lucy! And there she goes. Lucy, up here right now. I gotta put her inside because she's smelling too many smells. You're gonna go inside if you can't sit in your basket. Good girl. Okay, no, sit in your basket. So, we can see that that 1 penny was 1 out of all of these 100 pennies. So that makes it 1/100th. 100 pennies is the entire whole, right? That's the whole $1. 100 pennies is the entire whole. When we have 1 penny, we have a fraction of that whole. What's the fraction? How much of the whole do you have? You have a fraction of it, which means part of it, right? You have part of it. I remember what I was going to do, but I can do it here. If I don't even have a whole leaf here, right? Because I have already part of it is cut out of this leaf here, right here, which means I have only a fraction of it. I don't have the whole leaf. Now for this one, I probably have 99 out of 100 parts of this leaf, don't I? But for that 1 penny, I have 1 out of 100 parts for that 1 penny. $5 pennies is 5 out of 100, or 5/100ths. That's how we say that. It's actually I'm going to put on a TH on there so you can see how I'm pronouncing it. It's actually 5/100ths is what it is. That's how you say that, all right? That's how I'm pronouncing it. But how you write it is, you write it like 5/100. But it's called 5/100ths. It's a part of the whole, 5 out of 100, instead of 1 out of 100. We have now 5 out of 100, and that equals a nickel. A nickel is worth 5 pennies. I didn't want to go in the back because the back is a little cool right now. And they usually aren't that noisy. Let's just we'll just look at what they're doing really quick. Because it's good to see other people work. It really is. It's inspiring. Maybe you want to do that kind of work. Maybe you someday want to figure out how to build a house. I was going to go get my coffee too. I want you to look at this. And what I want you to do is, I want you to, I'm going to put a box for every 5. So what we're going to do here is, I'm going to draw a box like this. For every 5, so 1 nickel. For every 5 pennies there, for every 5 squares, we're going to pretend like we're going to fill it up with pennies, but I'm only going to draw a box there. That box is going to be like a nickel, 5 pennies. And we're going to count. We're going to count how many nickels would it take to fill up that sheet, right? So what we're going to do is we're going to draw a box or an oblong circle for every 5. You know what? I'm not going to do it that way. I'm going to do it a little bit different way. Because it gets messy. All right, there we go. 1. I'm going to just draw a box. That's 5. That's worth 5 pennies, right? That box is worth 5 pennies. It's the size of 5 pennies. So I'm going to fill this up. So that box is representing 5 pennies, and I'm going to cover every one of those squares, little squares, with my large rectangle. Each one of those boxes are squares. Each one of those blue lines I'm putting in there, those are rectangles, right? We can see that a rectangle is long on 2 sides and short on the other 2 sides, where a square is actually the same size on all sides. That's what makes it square. It's got the same size on every single side. So this right here is a square, because that's the same size on every side, right? But this is a rectangle because it has 2 long sides and 2 short sides. Do you think that this is a rectangle too? Do you think that's a rectangle too? It is, because it has 2 long sides and 2 short sides. So this is a rectangle as well. Now we've got these all these blue bars. So we're going to do some counting now. Let's do some counting. How many blue bars do we have, including these 5 pennies? So we got to start with the 5 pennies to see how many nickels, because each one of those blue bars represents a nickel, right? So how many, and so does this. So we're just going to put one more blue bar over the top of this just so that we don't get confused, right? So we're counting the blue bars, and we're trying to find out each one of those blue bars represents 1 nickel. How many nickels does it take to make $1? Remember, if we filled all of that up with pennies, we'd have $1. Now we're going to fill each one of those blue bars up with a nickel. How many nickels would it take? I'm going to get a cup of coffee while you count those up. Yay! Yay! Look at that. In my Dare to Dream cup. Or Dream Big. You know I do. You know Dr. Feravich dreams big. Did you count those up? You're like an hour ago I counted them up. All right, whatever. Let's count them though. We're going to start here with 1. Can you see that? I don't think so. Not that well. Let's do it in black. I think you can see it better. 1, 2, 3, 4. Remember, each one of these represents a nickel, right? 5. And we're trying to find out how many nickels it takes to make $1. 6, 7, 8, 9, 10. Of course we have 10. We see the number 10 right here. And how about this? We have another 10, don't we? We already know. We already have another 10. So that's 11, 12. If we count on, we can figure it out. 13, 14, 15, 16, 17, 18, 19, and 20. Now, probably most of you already knew that because you could add 10 plus 10. 10 plus 10 equals 20. Now, we can add across this way. Or we can add like we usually do on our addition sheets, up and down, right? So we can do our 10 plus 10, because we had 10 here, right? We had 10 here, and we had 10 more here. So 10 plus 10. 0 plus 0 is 0. 1 plus 1 is 2. And it doesn't matter how small or how big that number is. We could add those across, but most of the time we add up and down. Why? Because it's easier as our numbers get larger. The sun is right there in my eyes. Right there in my eyes. I had no idea. Because we haven't been out here in the morning. This side, we haven't been out here. Early birds, we usually do our class inside, don't we? Okay, that was an awesome lesson. We're not done though. That was an awesome little lesson that we just did on the nickel. $10 pennies equal 10 out of 100 or 10 100ths. So that equals a dime. 10 pennies equal 1 dime. Now, of course, I'm going to ask you, how many dimes does it take to make a dollar? And we can do exactly the same thing, right? We can do exactly the same thing. We can count the number of boxes for each one of these rows that represent 10 pennies, right? And we can also just count the rows, can't we? Because each one of these, I'm going to make a bar here that represent all of these 10 pennies. And all I got to do is come down the side here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those boxes will fill up this entire chart, right? Or 10 of those rectangles will fill up all of those boxes. We know that. So there's another one. There's another one. There's another one. So let's fill it up. We already know that because the numbers are along the side, right? So we already know it's going to take 10 boxes, but we're going to go ahead and do it anyway because that's the way that we work. We're scientists and we make sure that we fill in every detail. All right, so yes, sure enough, to fill in all of those boxes, it took 10 rectangles. Each one of those rectangles is like a dime, right? Because each one of those rectangles is like 10 pennies. So we count them. We know we have 10, but now we're going to count by tens, right? To see how if we've got all 100 there. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to show you something else. 10 times 10. Remember, these are multiplication tables too, right? That's why I use these boxes. So we have a good count. 10 times 10 equal how many? 100 pennies. 10 pennies times 10 pennies equal 100 pennies. But right now we're asking how many dimes does it take to make a dollar? How many rectangles do we have there? We have 10. It takes 10 dimes to make a dollar. You see how that works? Each one of those rectangles represents 1 dime, right? Each one of these represents 1 dime. So how many of those do we have? We've got 10. So 10 dimes equal $1, right? Just great. I want to clean up my slide and go on to the next one. When you count the number of items in a row and multiply it by the number of items in a column, you can find the total number of items. And that's exactly what we just did. So when we count the number of items in a row, and we did, and I don't even have to do that. I don't have to count because it's already counted across here, right? So here's our count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Across the top, the row, I can count here 10 all the way down to here. So that's where we get the 10 times 10. And we can do that, whoops. So when you count the number of items in a row, here's our row right here. And multiply it by the number of items in a column. Here are the total number of items in that column, 10. You can find the total number of items that would fill up this entire box. So let's go back and look at I don't have to go back. I've got it right here. $10 times 10 equal 100. So what we did was we counted the number of items in this row, 10. We multiplied it by the number of items in one column, 10, and that will give us the total number of items. Oh, I'm so happy. This is going swimmingly. That's what I wanted to say. Swimmingly. It did yesterday, though, too. I was pretty happy with it yesterday as well. Actually, today's taking a little longer than I wanted. I was rushing yesterday to get it through in time. How many pennies are on the sheet? Oh, I did a good job with putting these slides together. I didn't realize I had this as the next question. Yay, good job. How many pennies are on the sheet? So what would we do? We would count the number of pennies across the top of one row here, which we know is 10, because there's our number 10 there, right there. That's why we use this multiplication table. So we can easily begin to figure out we can easily figure out the total number in those square boxes by using the numbers to help us across the top and across the side, the row and the column. So how many pennies do we have in the column, in one column? 5, right? Here's our 5. So when you count the number of items in a row and multiply it by the number of items in a column, you can find the total number of items. 10 times 5 equals 50. And we have Robert F. Kennedy on our 50-cent piece. We don't see those that often. We really don't use those that often. 50 pennies equal $0.50. We're going to talk about that in a minute. But 50 pennies, 50 cents, is half of 100. 100 is the whole dollar. 50 cents is half a dollar. Thought I was moving along and I was not. 25 pennies equal 25 out of 100, or 25 100ths, or 1/4. Now this is, I'm going to show you how that equals 1/4 in money. So counting quarters. So 4 quarters equal $1. 4 quarters equal $1. If I filled up this sheet here with all of these pennies, how many of these pennies would it take to fill up that sheet? Well, we could draw out. All right, so we've got that. So here is the same amount, 25, and I'm going to turn it like this. So this represents 25 pennies. Whoops. This shape is the size of 25 pennies. And look what we have there. We've got half a sheet. If we filled in those two areas, we would have half a sheet, right? Or 50 pennies. If we filled in the other half, we would have 100. So how many of those do we have? We would have, actually, we should do it the other way, shouldn't we? We should do it this way. 1, 2. 3, 4 to fill in. So each one of those represents 25 pennies. How many of those weird shapes does it take? How many quarters does it take? 4 quarters to fill up that sheet. 4 quarters equal $1. So what we want to do is we want to see, how did we get to this 1/4 right here? 25 pennies equal 25 100ths, or 25 out of 100, or 25 100ths. This is also a dividing line. How many 25s go into 100? 4 25s it takes to make 100. 4 times 5 is 20. Remember, during the summertime, you're memorizing your multiplication tables, right? Don't forget that we have our multiplication tables. All of them, your timetables charts, so you can memorize those, and we could see, and it only goes up to 12, but when we're working with money, it really does get to be a lot easier for us to learn fractions. Why? Why is it easier for us to learn fractions when we're doing it with money, like we're doing it today? Well, it's easier to learn fractions with money because you use money all the time. It's all part of what? It's all part of a whole. It's all part of $1. It's all part of a whole, whatever the amount is. Don't forget to memorize your timetables. Also, I can't believe we're way over time. Also, what you want to do is you want to memorize basic math facts as well. I told you that you want to memorize basic math facts if you are in the kindergarten, first or second grade. If you have not memorized these basic math facts, they're really going to help you when you do addition of larger numbers. So, if you're in the third grade going into the fourth grade, if you were in the third grade going into the fourth grade, you want to memorize your multiplication tables. If you're younger than that, you want to memorize, make sure you know, and you likely already do, know your basic math facts. If you're in the third grade or the second grade, you likely already know your basic math facts. But if you're in the kindergarten, first grade, you want to memorize them. And if you don't know your basic math facts and you're older than the kindergarten or first grade, you want to make sure that you know them. Beyond third grade, multiplication tables. All right, folks, that's all the time I have. We are already way over time. So all we did today was math. We didn't get to any phonics. It was supposed to be our phonics day. So we're going to have to sort of rearrange things a little bit and make sure that we have enough time for science, make sure that we have enough time for math, and make sure that we have enough time for phonics. I'll likely come in on back on Tuesday, and I'll likely do phonics on Tuesday, and we won't have any reading on Tuesday. I'll see. I'll decide. This is Dr. Annette Feravich. We're here in the classroom. I got to get going because we have to be back here at 9:15 for our Bookless classroom coming up that I really did a lot of preparation for, too, as well. I'm really excited about. So, Dr. Annette Feravich, I'm the teacher.